when a ray of light is passing from a denser to a rarer medium, this is denser medium, denser, and this is rarer. So suppose this is a ray of light and it bends away from the normal. You see, it might have gone if there is no refraction, but it bends away from the normal. So what if the angle of incidence is further increased? If I increase the angle of incidence, the ray further bends. If I increase the further the angle of incidence, this ray further bends away. And a stage will come when the ray just manages to graze out. So this angle becomes 90 degree with the normal. So when this happens, this angle will be called critical angle. So it is that angle of incidence for which the ray just grazes out when a ray is going from a denser medium to rarer medium. So when a ray goes from denser medium to rarer medium, then the angle of incidence, for which the ray grazes out or makes a right angle with the normal, is called critical angle. So suppose this medium has a mu and this medium has a refractive index 1 and a ray goes at a critical angle, so it just grazes out and you see this angle becomes 90 degree. So applying Snell's law, we have mu sin C is 1 into sin 90 degree. This angle is 90 degree, refractive index 1. So sin C is equal to 1 by mu, which implies C is sin inverse 1 by mu. This is what? Critical angle. The magnitude of the critical angle C is given by sin inverse 1 by mu. Please note down. Now come to the phenomenon of total internal reflection. So when a ray goes from a denser medium to a rarer medium, this is denser medium and this is rarer medium, such that the angle of incidence is more than the critical angle. This I is greater than critical angle. So for critical angle, the ray just grazed out. So once the angle of incidence become greater than critical angle, the ray simply gets reflected. This phenomenon is called total internal reflection. So when the angle of incidence is greater than the critical angle, when the ray passes from denser medium to the rarer medium, then the ray gets totally internally reflected. This phenomenon is called total internal reflection. This phenomenon is called total internal reflection. Now, this phenomenon is used in a number of devices called optical fibers. Optical fibers, they are in turn used as endoscopy. Total internal reflection phenomenon is used in the polishing of diamond. The diamonds are polished in such a way that with the help of total internal reflections, multiple reflections are caused. That is, brilliance of diamond. Sometimes we find in on highways, on a hot summer day on highways, we find that we can see a car coming from front and its image, thereby giving an illusion that there is some water on the road surface, and it happens in deserts, and this phenomenon is called mirage. So these are the phenomenons, these are the optical devices where total internal reflection takes place. Now, let us see the deviation of a ray when it passes from a denser medium to a rarer medium. Earlier we have seen deviation of a ray when it passes from a rarer medium to a denser medium, that is refraction at a single surface. This is also refraction at a single surface, but the ray is passing from a denser to a rarer medium. So suppose this is my surface which separates two media 1 and mu, and at this place I have an incidence ray with angle of I less than critical angle. So what happens? This ray passes like this. So we define deviation is the angle by which the ray deviates from its original path. So this was the I and this was the R, so deviation will be equal to this R minus I. So this is the deviation. So here we have the plot. We will plot I, angle of incidence, along the x axis and deviation along the y axis. So as the angle of incidence is increased, so deviation will increase like this. So till this I becomes critical angle, this deviation will be equal to R minus I. So till this I becomes equal to critical angle. So when it is somewhat less than critical angle, this is 90 degree. And the deviation at that time will be, this R becomes 90 degree. So this is pi by 2 minus C. So when this becomes this. Next, when this is mu and 1, when this I is greater than critical angle, the ray simply reflects, total internal reflection takes place. And so you see, this is suppose I, this will be also I. So this is deviation, that is pi minus 2I. So here the function is, previously function was deviation as R minus I, pi minus 2I. So when it is just greater than critical angle, pi minus 2C. Pi minus 2C is double of this. This is pi minus 2c. You see, if I multiply this by 2, we will get pi minus 2c. So, just angle of I greater than c, the deviation again comes to this place. So, now this deviation is pi minus 2i, this is a straight line, it decreases like this. So, this is how deviation will vary, will depend on I. When the ray is refracted, it is going from a denser medium to a rarer medium. So, any deviation you see here, if this is the deviation, then this is, there are two angles of incidence for which we can have the same deviation. So, but if but this deviation means deviation from here to here can be caused only by only one angle. So, you may be asked, what is the maximum deviation that can be caused by two angles? So, this is the maximum deviation that can be caused by this angle and this angle, this angle and this angle. So, this is the maximum deviation, and this deviation from here to here only can be caused during total internal reflection. So, this is very important result.